Prevalence is a term used in epidemiology and public health to describe the proportion of individuals in a population who have a particular disease or condition at a specific point in time or over a period of time. Prevalence is usually expressed as a percentage or a rate and is an important measure of the burden of disease in a population. Prevalence can be calculated in different ways depending on the study design and data sources. For example, in a cross-sectional study, prevalence can be calculated as the number of individuals with a disease or condition divided by the total number of individuals in the study population at a specific point in time. In a cohort study, prevalence can be calculated as the number of individuals with the disease or condition divided by the total number of individuals in the study population over a period of time. High prevalence rates may indicate a need for increased screening, prevention, and treatment programs, while low prevalence rates may indicate successful disease control efforts. Population. The population can be defined in different ways, depending on the nature of the research question and the research objectives. Some common ways of defining the population include 1. Target population. This refers to the group of individuals, objects, or events that the researcher is interested in studying. For example, if the research question is what is the prevalence of diabetes in adults aged 40 to 60 in the United States, the target population would be all adults aged 40 to 60 in the United States. 2. Accessible population. This refers to the portion of the target population that the researcher has access to and can feasibly include in the study. 4. Example, if the target population is all adults aged 40 to 60 in the United States, the accessible population might be those who can be reached through a specific survey or sampling method. 3. Sampling frame. This refers to the list or database of individuals, objects, or events from which the sample will be drawn. For example, if the accessible population is all adults aged 40 to 60 in the United States, the sampling frame might be a list of registered voters or a database of phone number. Confidence interval. In statistics, a coefficient is a numerical value that represents the strength and direction of the relationship between two or more variables in a statistical model. A confidence interval for a coefficient is a range of values around the estimated coefficient, within which the true value of the coefficient is likely to fall with a certain degree of confidence. For example, in a linear regression model, the coefficient represents the change in the response variable, dependent variable, associated with a unit change in the predictor variable, independent variable. A confidence interval for the coefficient can be calculated using statistical software and is typically reported with a level of confidence, such as 95% or 99%. This means that the true value of the coefficient has a 95% or 99% chance of falling within the calculated interval. The width of the confidence interval depends on the sample size, the variability of the data, and the level of confidence chosen. A wider interval indicates greater uncertainty in the estimate of the coefficient, while a narrower interval indicates greater precision. Confidence intervals can help researchers assess the significance of a coefficient and make decisions about the importance of variables. In research, a variable is a characteristic or attribute that can be measured or manipulated in a study. Variables can be divided into two main types: independent variables and dependent variables. Independent variables are the variables that are manipulated or controlled by the researcher to study their effects on the dependent variable. For example, in a study investigating the effects of exercise on weight loss, the independent variable would be exercise. Dependent variables, on the other hand, are the variables that are affected by the independent variable. In the above example, the dependent variable would be weight loss. Variables can also be classified as continuous or categorical. Continuous variables are those that can take any value within a certain range. Examples include age, height, and weight. Categorical variables, on the other hand, are those that can be divided into distinct categories or groups. Examples include gender, race, and education level. Validity. Validity in research refers to the degree to which a study or experiment measures what it claims to measure. It is a crucial aspect of research as it ensures that the findings and conclusions are accurate and reliable, and can be applied to the larger population. There are different types of validity in research, including 1. Internal validity. This refers to the degree to which a study is free from biases and confounding variables that could influence the results. 2. External validity. This refers to the degree to which the findings of a study can be generalized to other populations or contexts. External validity is important in ensuring that the results of a study have broader applicability beyond the specific sample or setting. 3. Construct validity. This refers to the degree to which a measurement tool or instrument accurately measures the concept or construct it is intended to Measure. Construct validity is important in determining whether a study has accurately measured the intended variables. Validity is essential in research as it ensures that the findings are credible, trustworthy, and can be used to make informed decisions or recommendations. Reliability. Reliability in research refers to the consistency, stability, and accuracy of the measurements or results obtained from a research study. A research instrument, such as a questionnaire, survey, or test, is considered reliable if it consistently produces similar results when administered under the same conditions. There are different types of reliability measures that can be used in research, including 1. Test-retest reliability. This refers to the consistency of results obtained from the same test or measure when administered to the same group of participants at two different times. 2. Inter-rater reliability. This refers to the consistency of results obtained when different raters or observers assess the same behavior or phenomenon. 3. Internal consistency reliability. This refers to the consistency of results obtained from different items or questions that measure the same construct or variable. 4. Parallel forms reliability. This refers to the consistency of results obtained from two different versions of the same test or measure that are designed to be equivalent. A high parallel forms reliability indicates that the two versions of the test produce similar results. Overall, reliability is an important consideration in research as it ensures that the results obtained from a study are consistent and accurate. This helps to ensure that the conclusions drawn from the study are valid and can be applied to other populations or situations. Methodology. Methodology in research refers to the overall approach or strategy used by the researcher to conduct the study and achieve the research objectives. It encompasses the theoretical and philosophical underpinnings of the study, as well as the methods and techniques used to collect and analyze data. There are different types of research methodologies, depending on the nature of the research question, the research design, and the data collection and analysis. Methods. Some common research methodologies include 1. Experimental methodology. This involves manipulating one or more variables to observe the effect on the outcome variable, and is often used to establish cause and effect relationships. 2. Survey methodology. This involves collecting data through questionnaires or interviews, and is often used to collect data on opinions, attitudes, and behaviors. 3. Qualitative methodology. This involves collecting data through observations, interviews, or focus groups, and is often used to explore complex phenomena or subjective methodology includes factors such as the research population, sampling methods, data collection instruments, data analysis techniques, and ethical considerations. Literature review. In research, a literature review is a critical analysis of the existing body of knowledge on a particular research topic. It involves systematically reviewing and evaluating all relevant published research, scholarly articles, and other sources of information related to the research question or topic. The purpose of a literature review is to identify gaps, inconsistencies, and contradictions in the existing research and to provide a theoretical framework for the research study. The literature review is also used to identify key concepts, variables, and theories that will guide the research design and data analysis. A literature review typically includes the following elements. 1. Background. Information on the research topic. This provides context and helps to establish the importance of the research question or topic. 2. Scope of the review. This defines the boundaries of the review and specifies the types of sources that will be included. 3. Search strategy. This describes the methods used to identify and select the sources that will be included in the review. 4. Critical analysis of the sources. This involves evaluating the quality and relevance of each source and identifying key themes, concepts, and findings. 5. Synthesis of the sources. This involves organizing the findings from the sources and identifying gaps, inconsistencies, and contradictions in the existing research. 6. Conclusions and recommendations. This summarizes the key findings of literature review and provide recommendations for future research.